Within the hallowed halls of scientific history, where myth often intertwines with fact, one figure stands as a monumental titan, his legacy etched into the very foundations of modern science. This is the story of Robert Boyle, the man who would earn the revered title, the father of modern chemistry. Our journey begins not in a sterile, modern laboratory, but amidst the dusty, mystical world of 17th century alchemy. We see a young, aristocratic Boyle poring over ancient texts, his mind captivated by the alchemist's quest to transmute base metals into gold and discover the elixir of life. His intellectual curiosity, however, could not be confined to old manuscripts. Encounters with figures like Galileo Galilei ignited a spark within him, a desire to move beyond ancient dogma and seek truth through observation. Upon returning to England, he established a cutting-edge laboratory at Oxford. Here, surrounded by alembics, retorts, and furnaces, Boyle began to replace the cryptic mysticism of alchemy with the rigorous, systematic process of experimentation, laying the groundwork for a new era of scientific inquiry. In 1661, the world of science was shaken by the publication of a revolutionary text, the Sceptical Chymist. This was Boyle's magnum opus, a direct and powerful challenge to the established order. With meticulous logic, he dismantled the classical Greek theory of the four elements, earth, air, fire, and water, which had dominated scientific thought for nearly 2 millennia. Instead, he proposed a radical new concept, that true chemical elements were the primitive, simple, and unmingled bodies of matter. These foundational building blocks, he argued, could combine to form all the complex compounds we see in the world, a definition that remarkably foreshadows our modern understanding of elements and has since become a cornerstone of chemical science. Boyle's commitment to empirical evidence found its most famous expression in his work with the air pump. Alongside his brilliant assistant, Robert Hooke, he constructed a sophisticated vacuum chamber, a marvel of 17th century engineering. With this device, they conducted a series of groundbreaking experiments that were as theatrical as they were scientific. In one of their most famous demonstrations, they placed a feather and a stone inside the chamber and pumped out the air. As the two objects were released, they fell at the same rate, a stunning visual refutation of Aristotle's long-held belief that heavier objects fall faster. It was through this work on gases that Boyle formulated his most enduring principle. He meticulously measured how the volume of a gas changed as he altered the pressure upon it, discovering a precise mathematical relationship, that for a fixed amount of gas at a constant temperature, pressure and volume are inversely proportional. This fundamental principle, now known as Boyle's law, remains one of the first and most important gas laws taught to students of chemistry and physics worldwide. Beyond his individual discoveries, Boyle's greatest contribution was perhaps his relentless advocacy for a new way of doing science. This fellowship was dedicated to advancing knowledge not through ancient authority, but through collaborative, transparent experimentation. For Boyle, this pursuit was not at odds with his profound religious faith. Rather, he saw science as a way to understand and glorify God's creation, a testament to the intricate and orderly nature of the universe. In the end, Robert Boyle's legacy is not just a law or a book, but a method. He transformed chemistry from a mystical art into a rigorous, evidence-based science, establishing an intellectual framework that has guided scientific discovery for centuries and continues to shape our world today.